which is titled as Digital Dice using STM32 Nucleo Board, which I have completed under the subject Artos. This project is simple yet interesting embedded system application where a 7-segment display and a push button are used to simulate the rolling of a dice. When the button is pressed, the STM32 microcontroller generates a random number between 1 and 6 and the number is displayed on the 7-segment display. Through this project, I have learned how to handle input and output peripherals using the STM32 Nucleo board, implement random number generation, and manage button-based events in the real time. The main objective of this project is to design and implement an electronic dice that works just like a real dice but is operated electronically. By pressing a button, the microcontroller produces a random number and that number is displayed instantly on the 7-segment display. This project demonstrates a real-time input detection, random logic, and output display control, which are all fundamental concepts in RTOS and embedded system. The components required to build these projects are a STM32 Nucleo C031C6 board, which is the main microcontroller used for processing, then a common cathode 7-segment display for displaying the numbers, a 7 current limiting resistors of 220 ohms each to protect the display LEDs, and a push button for generating the input signal to roll the dice. The software used for programming is Wokwi software. Now let us understand how the circuit is connected. In the circuit, each of the 7 segments of the display labeled from A to G is connected to one GPIO pin of the STM32 Nucleo board through a resistor, as we can see in the figure. The resistors prevent excessive current from damaging the LEDs in the display. The connections are as follows. So the PB0 of port of the Nucleo board is connected to the segment A of the 7-segment display. Similarly, PB1 is connected to the segment B, PB2 is connected to the segment C, PB3 is connected to segment D, PB4 is connected to E, PB5 to the F, and PB6 to the segment G. Here we can see PB2, PB5, PB4, PB6, etc. All ports are present on the Nucleo board itself. Since the display is common cathode, the common terminal which we can see here is connected to the ground. The push button is connected to PA0 and internally configured as input pull-up in the code. This means the pin normally reads high, and when the button is pressed, it connects to ground, giving a low signal. When we press the button, the STM32 detects this low input and triggers a new dice roll. Now, let us look at the working principle. The working principle of this digital dice is simple yet effective. When the system starts, all segments of the display remains off. Once the button is pressed, the STM32 microcontroller reads the low signal on the pin PA0, and executes a random number generation function. The random number generated is between 1 and 6, representing the digital output. The microcontroller then activates the corresponding combinations of segments on the 7-segment display to show that number. For example, number 1 lights up only segment B and C. Then number 4 lights up segment B, C, F and G. Similarly, number 6 lights up A, C, D, F and G. Every time the button is pressed, a new number appears, making it act exactly like a real dice. Now let us look at the code, which is the most important part of the project. So here the step 1 includes defining the segment pins. So here we can see here the array segment pins stores the 7 output pins that control the 7 segment of the display. Then we have also defined the button pin. The push button is connected to PA0 of the STM32 board. The next part comes to define the dice patterns. This two-dimensional array defines which segment should glow for each dice number A 1 indicates the segment should be on and A0 means it should be off. Then now let us look at the functions of the code. So first, in the setup function, all 7 segment pins are declared as output. The push button is declared as the input pin with an input with an internal pull-up register enabled. The random seed and the logarit bracket 0 line helps in generating true random numbers using analog noise. The next comes display function. This function takes the generated random number as input and lights up the appropriate combination of segments to display the correct number on the 7 segment display. Now let us move to the main part of the code, which is void loop. In the main loop, the program continuously checks of the button. When a falling edge, high to low, transaction is detected, it waits for 50 milliseconds to remove noise. This is known as debouncing. Then a random number is generated between 1 and 6 is and displayed on the 7 segment display. The variable last state ensures that one press only triggers one random roll, preventing multiple detections for a single button press. Now, let us look at the output. When we press here, when as you can see on the screen, when I press the button, the 7 segment display shows a random number between 1 and 6. Each press gives a new number just like rolling a dice. This verifies that our STM32 nuclear board push button and 7 segment display are working together perfectly. Now let us look at applications and advantages of the project. This digital dice project may be simple, but it has many practical applications. Firstly, it can be used in electronic games and interactive learning projects. Then, it helps students understand GPIO handling, debouncing logic, and random number generation in microcontrollers. It can also be extended further to multiplayer electronic games or automated systems. The main advantages are it is low cost, then it is simple and clear demonstration of real-time processing concepts. In conclusion, this project on digital dice using STM32 nuclear board successfully demonstrates the use of RTOS concepts such as real-time event handling and input management. I learned how to interface digital inputs and outputs, apply debouncing techniques, and use random functions to generate unpredictable results. Thank you very much for watching my presentation. I hope you found it informative and interesting. Thank you so much.